So we have a conical tank that stands on the ground, and suppose we pump water into this inverted right circular cone at the rate of 5 cubic feet per minute. So this is when it says cubic feet, so this is feet cubed, so that's volume per minute. So it gives you the rate of change of volume with respect to time. So that is equal to 5 cubic feet per minute. So we are given the rate of change of volume. The tank has height 6 feet, so it stands at a total of 6 feet. And the radius of the top is 3 feet. The reason why we are given this information is because this gives us the relationship in general between the height of the cone and the radius of the cone. So height divided by radius in general is in the ratio 6 divided by 3. So this tells us that h over r is equal to 2. So h, the height of the cone at any instant, is twice the radius. So this information helps us find the general relationship between the height and radius at any instant as the water level keeps increasing. So what do we mean by that? So suppose the water level is here up to this point. Then at this moment, again, if we look at the height and the radius, it'll be in the and the relationship between the two will be height equals twice the radius at any instant. So that's an important piece of information. What is the rate at which the water level is rising? What they're really asking us is, what is the rate at which the water level is rising, which is dH over dt. So dH by dt is the rate of change of height, which is the water level with respect to time, at the instant. So this is what we have to find out, at the instant when the water is 2 feet deep. So at the point when h is 2 feet deep, we have to figure out dH by dt. The rate of change of volume with respect to time is given, and that is 5 cubic feet per minute. So let's look at this equation. V is equal to 1/3 by r squared h. So notice that V, the volume, as the water level increases, the volume of water in the conical tank is also changing, right? So that's a variable. As the water level rises, the radius of the surface on top is also increasing, so that's a variable. And h, the height, is also increasing, so we have this is a variable, this is a variable, and this is a variable. So V, R, and H, all three are variables. However, we need to find the rate of change of height with respect to time when the height is given. So the radius or the rate of change of radius is not given. So what we'll do is we'll change this equation and write it in terms of h alone, which means I go 1/3 pi. I'm going to write the radius in terms of height. So height divided by 2 is equal to radius. So height divided by 2 is radius, the whole squared, h. So simplifying, I get 1/3 pi h cubed, because this is h squared times h is h cubed divided by 8. So now this is equal to 8 times 3, 24. 1/24 times pi times h cubed. So now we'll differentiate both sides with respect to t. So dv by dt is equal to pi over 24, which is a constant, times h is also a function of time. So it's going to be 3h squared. Remember, we are using the chain rule, times dh by dt. Now we plug in whatever we know. So dv by dt is 5 equals pi over 24 times 3, h is 2 feet, so 2 squared, times dh by dt, which is the unknown. So now we have to just solve for dh by dt. So that is 5 equals pi, and then we have 2 squared is 4, 4 3s are 12, so that is 12 divided by 24 dh by dt, and that is 5 equals 12 times 2 is 24, so that's pi over 2 dh by dt. Now we solve for dh by dt, so it's 5 times 2 over pi, so we multiply both sides with 2 divided by pi, and clearly that's the reason why we multiply both sides by 2 divided by pi, because we're trying to get rid of pi over 2 on the right side, and that's equal to dh by dt, and that is 10 over pi is equal to dh by dt. dh by dt is the rate of change of height with respect to time. The unit of height is in feet per, and the unit of time is minute.